Here's some help with question 18 from chapter 6-1 of Sapling Learning. So we're asked to determine the concentration of HBr hydrobromic acid solution if a 60 milliliter aliquot of this solution yields 0.5108 grams of AgBr silver bromide when added to a solution with an excess of silver ions. The KSP of AgBr is 5.0 times 10 to the minus 13. So 10 to the minus 13 is a fairly small number, so that's telling us that silver bromide is fairly insoluble. So what's going on here is that the silver ions that we add are going to precipitate the bromide ions that were in the HBr solution, and we're going to end up with a solid. We filter that solid out of the solution and dry it and weigh it. It's called gravimetric analysis, and that gives us a 0.5108 grams of silver bromide. So I've kind of illustrated here the reaction that's going on. So our HBr reacts with the silver ion that we have in excess to produce the precipitate silver bromide and leftover H plus ions in solution. The H plus ions, again, are kind of a spectator ion. So in fact, HBr is what we call a strong acid, which means it's going to completely break apart to give us H plus ions and bromide ions when we add that to water. And so what's really going on is the reaction between the bromide and the silver, represented by this reaction. So bromide plus Ag plus gives us AgBr solid. So this is the reverse of a solubility product constant reaction, and I just wrote the KSP out here to remind us that this is telling us that the AgBr is fairly insoluble. And since we've got an excess of silver ion right here, Le Chatelier's principle would tell us if we have a lot of that, it's going to shift the equilibrium towards the product side. So we can imagine that essentially all of the bromide reacts. So all of the bromide that we have initially in our solution is going to react to form this solid. So what are we looking for here? We're looking for the concentration of the HBr solution. So we're looking for that concentration. Well, how would we find that? Well, that's equal to the moles of HBr divided by the total liters of that solution that we have. All right, so I've told you that we have one bromide in every HBr, so this is going to be the same as the moles of bromide divided by the liters of solution. It also turns out from the stoichiometry of this reaction right here that we see that we have 1 mole of silver that reacts with 1 mole of bromide that we have. So the moles of bromide are going to equal the moles of silver bromide that we formed, right? So for every mole of bromide that we have, we're going to make 1 mole of silver bromide as a product. So moles of bromide will equal moles of silver bromide divided by liters of solution. So do we know any of these things? Well, we don't know moles of bromide, but we do know grams of bromide. So from grams of bromide, we can use the molar mass of bromide to find the moles of silver bromide. So do we know total liters of solution? Well, we don't know. Well, we do know total liters of solution because we were told that we have a 60 milliliter aliquot of this solution. So that's going to be 0.06000 liters of that solution. So we do know that in this case. And so now all we have to do is do this conversion of grams up here to moles of silver bromide. And that will equal moles of bromide, which equals moles of HBr, which is what we need to calculate the HBr concentration. So moles of silver bromide divided by liters of solution is equivalent to moles of HBr divided by liters of solution. So it turns out that that problem is pretty straightforward, and we didn't actually have to do any KSP kind of calculations at all. And this is a standard kind of calculation that you would do when doing something called gravimetric analysis.